6.5 Part 1, Solving Square Roots and Other Radical Equations. All right, if you want to solve a square root equation, what you want to do is isolate the square root. So get it on one side of the equation by itself, and then you're going to square both sides. Make sure you check your answer. All right, so if I want to isolate the square root, I need to subtract the 3. So on the left side, 3 minus 3 will cancel. So we're left with the square root of 2x minus 3 equals 5. Okay, so from there, to undo this square root, remember all this that's under the square, it's really like in parentheses, even though there isn't one. So when I square it, the whole thing will, square root will cancel with the squared. So then I need to square this side. So we're going to get 2x minus 3 equals 25. Okay, finish this off. You can add the 3. 2x equals 28, and finally divide by 2, and x is 14. Okay, so to check the solution, there will be some that don't work. I don't think on today's assignment, but on tomorrow's. So it's a good idea to make sure you know how to check these. All right, so I'm going to put my answer that I got back in for x. So if we do that, we get 3 plus, so 28 minus 3 is square root of 25 equals 8. 3 plus 5 equals 8. Yep, it checks. All right. Why don't you pause your video and try the second one. So go ahead and try this one, and then then go ahead and check your answer. Okay, you can check your answer. You should have gotten x equals 6. And then remember when you check to use the original equation. So don't use the equation when you've already isolated that radical. Use that original equation. All right, let's try another one. What if instead of the square root, we have the cubed root or the fifth root? You're going to do the same exact thing. So isolate that root, which in this one it's already done. And then what's the opposite of taking the cubed root of something? Taking something to the third power. So that's how we're going to undo cubed roots. All right, so right away this one's already set up that you can just take both sides to the third power. Again, we're not taking what's under the radical to the third power because the third root and the third power cancel. So we just are left with 2x minus 4 equals negative 2 times negative 2 times negative 2. What would that be? All right, so negative 8. And then you can solve for x. X equals negative 2. Okay, if you want to check this one, go ahead and plug it back in. So we've got x to be negative 2. So we're going to take the cubed root of negative 8. Does that equal negative 2? Yep. Negative 2 times negative 2 times negative 2 is negative 8. So it checks out. So negative 2 is our answer. All right, this next one has an extra step to it because you have the fifth root, but then you also have x plus 1 to the third power. So we're going to have to do an extra step at the end. But still, our first step is to isolate that radical. So why don't you guys work on getting rid of the 1 and the 3. So go ahead and pause the video. If you know how to finish it, go ahead and finish it. Okay, so we wanted to subtract the 1. That got us down to 24. And then for that 3, if it's right beside it, that means you're multiplying it. So to undo that, you want to divide both sides by 3. So now we're down to the fifth root of x plus 1 cubed. So we can do the same thing we've been doing, is take everything to the fifth power. But let's not evaluate 8 to the 5th yet, because we're going to find something that will be easier than taking 8 to the 5th power. All right, so over here, if we take the 5th root and the 5th power, those are going to cancel. So we're just left with x plus 1 all to the 3rd power equals 8 to the 5th power. All right, from there, we want to undo that 3rd power. So kind of like the 5th root and the 5th power are opposite. So we're going to do the opposite there and take the cubed root of both sides. Okay, so what's going to happen on the left side is the cubed root and the 3rd power cancel. So we're left with x plus 1 equals the cubed root of 8 to the 5th. I'm just rewriting that because I know what the cubed root of 8 is. Then I can take that number to the 5th power. So we're going to get x plus 1 equals the cubed root of 8 is 2, 2 to the 5th. So we get x plus 1 equals 2 times 2 times 2. So that'd be 8 times 2, 16 times 2, 32. Finally, one last step, we want to subtract that 1. So x equals 31. Okay, and again, if you want to check it, the ones you really need to check are when you have variables on both sides of the equation. We'll get to those, more of those tomorrow. But it is a good idea to get in the habit of checking these, just so you don't forget to check the ones that sometimes the second answer won't work. Okay, so if I put in 31, so we end up getting 3 times the 5th root of 32, all to the 3rd power, plus 1 equals 25. So 3 times 2, the 5th root of 32 is 2 to the 3rd. So 2 to the 3rd would be 8 times 3 is 24. And we can see that it checks. Okay. All right, so your answer again was the 31. So there's another way to do this type of problem. We're going to look at it right below. So if your problem is written as a fraction exponent instead of a radical, we can think about taking the reciprocal power to both sides of the equation so that we undo that exponent. So I have 6x plus 9 to the 1/3 power. We could also think of this as the cubed root of 6x plus 9, all minus 5 equals -2. So over here we would get rid of the 5 and then take everything to the 3rd power. It's basically the same thing, just take everything to the reciprocal power. So let's try this. So we're going to move the 5. So then we get 6x plus 9 to the 1/3 power equals 3. So here's where we want to raise it to the n over m power. So right now ours is 1 over 3, so our m is 1 and our n is 3. I want to flip that over, take the reciprocal, so then it's going to be 3 over 1. I'm going to take both sides to the 3 over 1 power. So when I take 1 times 3, I get 3, and 3 times 1, I get 3. So that's just going to be to the 1st power, or just have 6x plus 9. So 6x plus 9 equals 3 to the 3rd, 3 times 3 times 3, 27. So I can subtract the 9. And finally divide by 6. Okay, so if we want to check this, then we can put that 3 in there. So it becomes 6 times 3, 18 plus 9 is 27 to the 1/3 power, minus 5 equals -2. 27 to the 1/3 power, remember, is just the cubed root of 27. So So you have 3 minus 5. Does that equal negative 2? Yep. So it checks. Okay. So when you get to a problem like this, you can do it this way, or you can just rewrite it in radical form. And after you get rid of the 5, then take the third power to each side. Okay. So we'll do more like this tomorrow, but this should be enough to get you started on your homework assignment for tonight on Go Formative. Okay. All right. Meet me at office hours if you guys need help.